This week, it's my pleasure to introduce Joe Tulenko as our speaker. So it is the only talk we have this afternoon. I think we'll probably expect to hear about a 20-minute talk from Joe, and then we'll have a decent amount of time for Q&A after that. I met Joe in Buffalo when he was still a graduate student working with Jason Briner, and Joe finished his PhD in Buffalo in February 2022. And his project was basically about using cosmogenic exposure dating to date moraines, bold erratics, sculpted bedrock and such in a lot of work in Alaska. And he also had a project in Colorado. And hopefully many of you have seen Joe's papers on these projects. He came up with some really elegant and exciting work. So he's now a postdoc at Berkeley Geochronology Center. He's working with Dr. Greg Balco, and I see Greg is on the line here today, which is great. And Joe's working on the ICE-D project, which is a tool for the community to help visualize and analyze large data sets of cosmogenic nuclide measurements from all around the world, including the Western US. And as part of that project, sort of an outgrowth, he's been working on geospatial visualizations that include the Alaska Paleoglacier Atlas, and he's going to talk about that a little bit today, among other visualization applications. So I think he changed his talk title a little bit. So the title is The ICE-D Project and 3 Methods for Displaying and Analyzing Geospatial Data Served by ICE-D. So with that, Joe, you should be able to share your screen whenever you're ready.
Okay. So let's see. So can everyone see that full screen? Yeah, good. Okay. Let's see. So I'm going to just turn my mouse really quick into the laser pointer. Cool. Oh shoot. I'm all the way at the end of my talk. Hang on. Let me go to the beginning. Okay, so hopefully everyone can see this okay. Let me know if not. Laser pointer. Okay, so as Joe said, I'm going to be talking mostly today about what I've been doing for the last year with Greg Balco in Berkeley on the ICE-D project. And I'm going to be sharing a couple of methods that I've been working on for displaying and analyzing geospatial data, specifically served by ICE-D. Okay, so briefly for the talk layout, I'm just going to go over cosmogenic nuclide exposure dating, and then I'm going to talk about the ICE-D project and give an overview of why we think or we feel that the ICE-D project itself is necessary for the community. And then I'm going to jump into these 3 examples that I've been alluding to that are geospatial applications with ICE-D. So that would include the Alaska Paleoglacier Atlas that Joe had mentioned that I've been working on. We also have a means of connecting to ICE-D data through your own personal GIS desktop application, such as QGIS and ArcGIS, through this web feature service. That's what WS is. And then my last example, I've been working on a web application that's done in a Python-based environment that includes some interactive plotting, which includes both plotting in data plot space and then also in map space as well. So to start, cosmogenic nuclide exposure dating uses this shallow accumulation of rare elements in the Earth's surface to quantify rates and dates of quaternary Earth surfaces and processes, so almost exclusively over the last 2.5 million years or so. And so currently the community itself has generated over 15,000 measurements published worldwide since the 90s. And that's what I'm showing in this figure here in the background. All of these individual points are cosmogenic nuclide measurements. And I can get into this a little later if people are curious, but the color coding here basically separates exposure ages and cosmogenic nuclide measurements based on what we call applications, so different ways that we apply cosmogenic nuclide exposure dating. So for example, the dark purples here are for our Greenland ice sheet database. All of the reds that are worldwide in the high mountain areas, you might have guessed, are for the Alpine database. And then orange, for example, here is part of Antarctica, among some other applications that we have in the database currently. So briefly, cosmogenic nuclide exposure dating relies on this process of the atmosphere, our atmosphere, being constantly bombarded by primary cosmic rays that originate from far outside of our solar system, from these supernova explosions. And the rate at which the cosmic rays are constantly bombarding our atmosphere is somewhat constant through time. And so all of these cosmic rays that we call these charged particles are constantly bombarding Earth's surface, or constantly bombarding Earth's atmosphere. And when they do, they strike particles in the atmosphere with enough energy to split nuclei into new nuclides, and enough energy left over continued to produce these cascading effect of long chain reactions. And all of these chain reactions make their way down to Earth's surface, still with enough energy that they can penetrate through the Earth's crust and make new nuclides in the Earth's surface. And I note here that this happens primarily from 0 to 4 meters depth, with diminishing concentrations lower with depth. So most of the production happens right around near the surface. And there are a variety of nuclides that we measure in the community that are produced from cosmic ray interactions. The list is here. So we have helium-3, beryllium-10, C14, among others. And through a lot of empirical work and theoretical work, we've been able to constrain the production rates of these nuclides in the rock surfaces through time. And so you can calculate an exposure age by measuring the concentration of the nuclides and dividing it by the production rate. And so this is a pretty powerful tool, given that you can measure cosmogenic nuclides in almost any surface on Earth. And so to sum up and sort of set the stage for why we think that the ICE-D project is quite necessary, to start, we have new data being published all the time. And so we start with our observations, which include sample locations, the chemical composition of whatever material you're trying to date, the actual nuclides themselves, and all this information that you need to know to then calculate an exposure age. And the community is ever evolving and growing and improving the methods for actually calculating an exposure age, going from the observations to the actual geological information. And then once you have your exposure ages, burial ages, erosion rates, etc., then the community makes these important contributions to science overall, such as ice sheet change, past ice sheet change, paleoclimate dynamics, seismic hazards, landscape evolution, all these really important contributions. And so we've been thinking that all of this sort of new and updated and everything that goes into exposure dating and sort of like this growth of the community requires a database tool that can grow and evolve with the community as well. It makes me think of, you know, as a grad student, all the time I spent collecting Excel spreadsheets that someone else had done or that I've been doing for sort of literature review, and then putting all of those exposure ages in the exposure age calculator online and doing this ad nauseum, and realizing that other people do that as well. So just as an example of a reason why you might have the need for this tool, among other reasons. So the ICE-D project, we try to employ what we call this users as developers model, where essentially we, as what we call the admin, that would be me and Greg, we provide the platform, ICE-D itself, and the tools to contribute to the database, which is sort of this little plus sign here, this file, and then also to use the database. And so over the past year, Greg and I have been working on training users to add data to the database, and that's been well underway. And actually, even before I joined the project, Greg had been doing that. And so if that's something that you're interested in, please email me or check in with me, because we actually have scheduled a couple of workshops this spring. And we would be very excited to have people join. And so now I think what I want to do is I want to spend some time talking about examples of what the community can do with the considerable information stored in the ICE-D database now. And so that's sort of the bulk of my talk today. So I'm going to talk about these three examples of what I've been able to do with ICE-D in sort of a geospatial space. So the first one I'm going to talk about is the Alaska Paleoglacier Atlas, which is a JavaScript library called Leaflet that sort of makes a web map, or a map that you can embed into web pages that's live and interactive. The next application I'm going to talk about, or I'm going to demonstrate, is this connection to my personal GIS desktop application. I use QGIS through what is called this GeoServer web feature service. And then the last example I'm going to show is this Python-based web development / interactive plotting I've been doing, where this Python-based library allows you to embed interactive plots into web maps, or into web pages. So to start with the Alaska Paleoglacier Atlas, this was a project from the early 2000s that was NSF supported, and the main goal of this project was to map the limits of the last ice age and pre-last ice age advances of glaciers in Alaska. And it resulted in the compilation of from the compilation of over 26 papers and 42 reference maps that were then digitized into georeferenced layers that were stored online. And so I helped Jason Briner, who was one of the early, I don't think Jason was actually a PI on this project. He might have been. I'm not exactly sure. But I helped the project sort of migrate over into the University of Buffalo in 2019 as a sort of side project during my PhD. And I made this updated map interface that includes some higher resolution base maps, and then like an easier way of downloading the data, whether you need an image or if you want to actually download the shape files that are used to create these layers. Included in this web page, I made this chronology page on the website that shows all of the current exposure ages across Alaska. And if you notice in the corner here or underneath, the last time this image was updated was in 2019. And so this is really just a static image, and it doesn't actually show the continuously updated amount of samples that actually exist or have been measured and published in Alaska. And so my goal was to sort of create an interactive map that could show all of these layers in a web map and have the most up-to-date data from the community of cosmogenic nuclide measurements embedded on the map. And so to do that, I use this leaflet tool, this JavaScript library that, as I said, allows me to display base maps from online sources. So, for example, you could do GEBCO, the bathymetric map of the Arctic, PGC, which does the Arctic GIS, and a few other options. And then overlay the useful geospatial layers. So that would be ICE-D data sort of in a point format, and then the map limits in Polygon. And in this leaflet library, I can overlay static files, so files that don't change, that are just kind of hosted along with the website, or you can get remote online sources here, such as data served from ICE-D. And so here is the interactive map page. I just have a screenshot for now, but if people are curious, I could show the website in this talk later. But what I have here is I have the latest version that includes a high resolution base map, a few different ones. So there's the GEBCO base map, and then also the Arctic DEM that PGC hosts live in ArcGIS. And then, of course, as I've been saying, ICE-D data served directly from the database. And so I'm just going to show a quick example from my PhD, actually, sorry, from my master's thesis. So I have the Arctic DEM overlain here by all of the samples from my master's thesis. So this is a glacial valley in the western Alaska range. So the mountains, the high mountains here are on the right side of the image, and ice was flowing from right to left. And there's this really beautiful sequence of moraines deposited in this valley here. And so our goal was to date all of these date all of these positions and reconstruct the glacier retreat. And so I'm overlaying what was mapped originally as the maximum extent of the last glacial maximum at this site. And what I'm showing here too is that the ages on this outermost moraine here that we dated are shown, I guess, by clicking on them. They show up little pop-ups, and I've set it up such that you can visit the individual site or the individual sample on the ICE-D webpage, or you could go to the site. So all of the boulders that we dated on this moraine grouped in one site. But what I'm going to show next is the actual sample in ICE-D. Actually, sorry, I'm going to show the site. So this site here, all of the boulders that we dated on this outermost moraine. So here they are. We dated 5 boulders on that moraine, and in ICE-D itself, this is what the web page looks like when you go to a site. So it has the paper that it comes from that we published in 2018. It has the list of samples and the site that they belong to. And then it calculates the exposure ages from those individual samples based on all of the information we put in the database. And then it has a little graphic here that shows that the moraine that we dated, the extent of the LGM at our site was somewhere around 20,000 years ago. So I can talk about this a little bit later. I'm not sure how much time I have left and if I need to keep moving on. But there are some more things that I want to include with the Alaska Paleoglacier Atlas, or some updates that I want to do, and those are listed here. I think that the mapped units, this blue line, should similarly be editable by the community and should be live and should be things that we can map out and grow and change. And the scale and accuracy, of course, would be improved along with that. And I have some thoughts about possible routes, but that would probably be for later discussion. So for the next application, I want to talk about displaying ICE-D data in GIS, so on your own desktop or online application. So if you have ArcGIS or if you have QGIS, we have created a way of displaying the latest version, the live, continuously updated version of ICE-D in your own personal desktop applications, assuming, of course, you have an internet connection. And so essentially, the sort of flow chart here, ICE-D, we write some SQL queries that package up the data stored in ICE-D into a digestible format for GeoServer, and then GeoServer itself creates this web feature service that you can open on GIS, or more so GeoServer hosts these web feature services that you can then open on ArcGIS or QGIS. And so I'm going to just go through a really quick example of what you can do with these layers. So what I'm showing here is the entire ICE-D Greenland database. I took this screenshot yesterday, so this is the most up-to-date version of what's in ICE-D. And so what you can do sort of in QGIS is you can identify individual samples, and then you can also almost query essentially QGIS based on logical expressions to sort of extract the data that you want. And so just as an example here, you can identify various features. So if you wanted to know what these samples were and all of the attributes associated with these samples, you can click on them. And the sort of information that we have packaged up to give to GeoServer to make this equivalent shapefile is listed here. So the latitude, longitude, elevation, sample information, name, what we call like what describes the actual sample, the sample page itself on ICE-D, the site page, the publication that it belongs to, and then we also display calculated ages from calculated surface exposure ages from each of these samples here. And so the next step I want to show briefly is using an expression to select the samples that you care most about. So let's say you want to select all of the samples that are in this box here on the western margin of the Greenland ice sheet, southwest margin. So you can use this expression essentially opening up the table where all of the data is stored to say, give me all of the samples that fall within this geographic box. And there they are, they're selected. So this is just an example of what you can do in QGIS now that the web feature service is live and anyone can access it. So now the last example I want to show is displaying ICE-D data online in this Python-based environment that I've been working on. So once again, we write SQL queries to package up the ICE-D data that's in the database into a format, this time for a Python web app library that is called Bokeh. There are several Python-based web app libraries. We just chose Bokeh because we liked the features that it provided. And so Bokeh is this Python-based plotting library. And I think one of the major attractions for Bokeh is that you can embed these interactive plots into web pages themselves. And so then I've created this online web page that's hosted as a Google App Engine that's part of the ICE-D project. And so I just wanted to show, I guess, essentially, once again, this West Greenland example. And so this time with the intention of actually doing some applications. So the example is constraining this post-LGM retreat of the southwest margin of the Greenland ice sheet. And so Bokeh makes these interactive data plots that show the data in time distance space here, where the longitude of the samples is plotted from west to east, and the age of your exposure ages is plotted from oldest to youngest in the top. So not only can you embed this time distance plot in your web page, but you can also embed a map interface that is interactive. So the really interesting and really cool thing about these plots is that you can zoom in on them, you can highlight individual samples to figure out what that sample is. And then as far as the map interface goes, there are available various online layers. I think it might also be potentially user-defined if you have a map, a geospatial map that you've stored online. It might be something that you can embed in one of these bokeh plots. But so I just wanted to show how this is actually interactive. You can zoom in and out in the actual web page itself. You can highlight a sample. And then if you are curious about this sample, you could go into ICED and find that example highlighted in the ICED page. So here's that sample that I highlighted, GRE-5. Turns out that sample suggests was exposed about 9.1 thousand years ago, and it belongs to this publication here. Okay, so to summarize, I kind of want to just summarize the examples that I showed and what I think should come next for these examples. And so for the Alaska Paleoglacier Atlas, what's next? I think, as I had previously stated, that we should update the mapping layers to make them as interactive as the ICED data. And then, of course, I'm sure there are others who are particularly interested in applying this concept to other regions outside of Alaska, such as the Western US. As far as the web feature service that is used in GIS, I'm curious, or I'm hoping to interact with folks who want to generate their own expressions to extract ICED for their own applications. So whether that's as simple as making figures for publications, that's something that you could use ICED for. You could extract whatever specific data you're looking for and plot it on a nice map and make some map figures for publications. Or if you wanted to actually do some analyses, I think that you could do that in GIS as well. And then for the Python-based ICED examples, I showed the Greenland time distance diagram, but I have a few other examples that I've been working on. And I'm really curious if there are others in the community who have some examples of their own that they want to work on. And then I would be very interested if there were people who want to learn how to make their own web apps. It's been a pretty awesome experience for me learning all of this stuff in the last year or so, and I'm excited to sort of share what I've learned. And so that's what this fourth point I'm making is please ask me about the ICED workshop schedule that we've made for the spring, and or if you are curious about scheduling some virtual tutorials with me in the event that you might not be able to make a scheduled ICED workshop. So with that, I think I will conclude my talk. Thanks for listening, and I'm happy to take questions.
All right. Thank you, Joe. Lots of really exciting things to think about here. Yeah, we got plenty of time for questions. So if anybody wants to go, just raise a hand or jump right in.
When do you plan on having those workshops?
Yeah, that's a great question. I guess maybe if Greg is on it quick, he could share the wiki page where we have our workshop schedule. We have one coming up in about 2 weeks in Reston, Virginia, and that one's pretty much full. That one's pretty set. But we have another one in April in San Bernardino that's focused mainly on tectonics and people who apply cosmogenic nuclide exposure dating to tectonic situations. And I think that's April, I think the 26th through the 28th. And then the last one that we currently have scheduled is for May, I think 16th to the 18th, something like that. It's right before the Rocky Mountain session, and it's in Denver. So we intended it purposefully to be scheduled for folks who might be attending GSA as well, so they could attend the workshop and then make their way up to Fort Collins afterwards. And that one we have maybe 4 or 5 people So that one's got
What
lots
do
of.
you plan to go over in the workshop?
So what we like to do in the workshop, it's about a 2.5 day scheduled event. There are a couple of steps that people need to take to get connected to ICE-D. So it's an online hosted SQL database that's on a server somewhere, and you have to essentially establish a connection to the server to look at the data. So we get folks set up with that. And then we also are prioritizing people who want to contribute data to ICE-D. And we've streamlined that process. So if people who have published data that they're currently sitting on that aren't in ICE-D, we're encouraging them to learn how to add it. And we do that through an online sort of admin page that's associated with ICE-D. So it's pretty streamlined. It's pretty well organized at this point. So we do a little bit of that sort of logistics stuff to get people caught up and connected with the database. And then we really focus on how you can extract data, what sort of SQL queries you want to make to extract data, examples, things like that. And then we try and get people to think about what they actually want to do with ICE-D. And so if people come with ideas for what they actually want to do with ICE-D, then we try to spend some time actually going over how they might approach specific problems. So the intention is for it to be very interactive, hands-on.
And then you also had one slide for your GeoJSON leaflet slide
Mm-hmm.
with you had a map of Denver with a couple little points on it. Are
Yeah.
those cosmogenic data points?
No, no, no.
I
That was just an example from the leaflet main page.
was gonna say, wow, those are peculiar.
Yeah, I don't know what they'd be trying to date out there.
That just caught my eye. Oh, and then my last question was, so in your map compilation, will that eventually, and Greg can maybe answer this, will like his and Roby's data from the planes and all that be incorporated into this ICE-D eventually?
Yeah. So
Wonderful.
so the map, so the main map I was showing with sort of the spread of all of the ages that exist currently in the database, certainly there are plenty of data that are missing from the database right now. And one of the applications that we're working on specifically in the Reston workshop that's coming up is expanding the Laurentide ice sheet application that we've made. So Allie Balter Kennedy, who's at Lamont, working with Jörg Schaefer, she came to us because she's writing a big compilation paper from the New England area Laurentide ice sheet. And so she's been adding data to the database, but we want to expand that to the whole Laurentide ice sheet. So
Yeah.
in short, yes, that data will eventually make its way
Is
into ICE-D.
has anybody been in touch with Will Odom at
Yes,
all?
yes.
Okay,
So he
okay.
he will be at the workshop. He's helping us host it essentially, and he's also going to be learning about it. So
Just curious.
yeah,
Oh, that's great. I'm excited. Getting our forces aligned.
yeah, yeah, for sure.
Jeff has his hand up. Jeff, go ahead.
Hey, thank you, Joe. God, this is just awesome. I just feel like this is like this breathtaking glimpse of of the future or something. So, bravo
Kind of
to
how I feel
you
about
and
it for sure.
yeah, you and Greg and your collaborators. Just a huge thank you for this product, this service. I think you're just beginning to see the ways in which it's going to be valuable.
Hmm.
I'm curious, just almost more curious about like just backstory, like pulling this thing together, the database itself, like what fraction of the samples did you find in the literature that you maybe they were missing some of the information that you needed to really bulk out a complete entry in the database, or is my skepticism unfounded and the community has actually been really great all along about including all the necessary info? Or like how did you deal with those inevitable real world challenges of trying to build something like this out of decades of literature?
I think that I think if Greg wants to speak on this, I think he'll have more to say about it than I do. But as far as I understood it, Jakob Heyman had made a really big contribution or a compilation Excel spreadsheet of a ton of exposure ages from across the world. And a lot of that got digested into the Alpine database, and that was sort of a big start. I think that there's been some groups who are a little hesitant about adding data to ICE-D, but I think that it's by choice. You know, you don't have to add your data to ICE-D if you don't want to. But if it's public, there's not a whole lot of incentive to not include it.
Well,
right?
if it's
Like
published, then somebody else will eventually add it. So, you know,
yeah,
this is Greg. Sorry, no video, but I can also field some of that. It actually isn't that bad. I mean, since the online exposure age calculators became widely used in 2007 or 8 or whatever, like, you've had to know all the information that you need to put it into the online exposure age calculator, right? So once you know that information, if you don't put it in the paper, then people will notice. So the sort of practice of, you know, people reading papers and reviewing papers, of immediately taking the data and putting it into the online exposure age calculator, I think kind of cracked down on people not having the data in their paper. So nearly all papers since that time include enough data to actually calculate the exposure ages. You know, there's not like what's in publications as regards background information is wildly variable. You know, some people don't tell you the lithology, and some people tell you the height of the boulders, but not the width. And, you know, there's like all this stuff. So basically, when we've, you know, people who are entering data, basically we just put in whatever is available. You know, there are actually some examples where samples are known to have been collected, but like sufficient data don't exist to actually recalculate the exposure ages, and like they're in there, but you just don't get an exposure age. So it's kind of the sort of approach has been like, you know, if you know it, put it in. And mostly you're going to have a reasonably good amount of data, and sometimes you're going to have a lot, and sometimes you won't have enough. In terms of like time and who did it and so forth, the whole thing got started when I actually came up with this whole sort of general concept of organized exposure age data that I was collecting from Antarctica, which had become too voluminous for spreadsheets. And then I wound up just entering a whole pile of data for Antarctica, which is Antarctica, right? So not that many people have been there, but still there's a few thousand exposure age measurements that have been made. And it actually didn't take that long. You know, it's it doesn't take that long to read a paper and enter the data relative to just reading the paper. So, you know, if you're sort of working in some area and reading a lot of papers in that field, it actually doesn't take long to get quite a lot of data sort of uploaded. Like everything that's in the Greenland database has been entered by, you know, I guess 3 or 4 people associated with Jason Breiner's lab over the last year or so. And some other collaborators now in Europe are also involved. The Alpine Glacier database, as Joe said, we started that off by ingesting a big pile of data that Jakob Heyman had already put together. But since then, it's probably grown by at least 30 or 40% just from people, you know, adopting an area that they're kind of interested in at the moment and entering a lot of data so that they can look at it synoptically, right? Like some folks in the French group associated with PH Blard did a lot of work on South America. Ben has done quite a lot of work on completing and maintaining the Western US part of the database. Joe's done a lot of stuff in Alaska. And so without like that much effort, if you just kind of make it part of your workflow, pretty soon you find that there's a lot of data in there. and then there tends to be a snowball effect, which has been most prominent for Antarctica, where since there's all these really obscure bits of information from all over Antarctica in there that nobody really knew about before because they were published in the Journal of German Polar Expeditions or whatever. You know, now having your data in this database for Antarctica makes it like way more discoverable. And so now there's a strong interest in anybody who's collecting and publishing data to make sure that their data is in there. I myself use it as my own sort of personal data management system for Antarctic research. So at any given time, I generally have quite a large quantity of unpublished data in there, which I do because it makes it so much easier to write papers about it. If I have it all in this like easily addressable structure, then it makes it much easier to make papers and figures and tables and plots and results and all that stuff. So, you know, it's that the sort of advantage of, you know, we don't sort of pretend that this is supposed to be an immutable archive. You know, if we find errors, we change them. We don't archive data that we know are wrong. And because it's kind of freeform, there's the opportunity for people essentially to discover that it's actually very helpful if you include data in this database. And we're attempting to give people the ability to do so, you know, on their own, so they can discover this for themselves. And if lots of people do that, then it gets more complete. And the result is that it's pretty complete. Like, I think basically everything that we know about for Antarctica is in the Antarctica database. Greenland's fairly close. I mean, for alpine glaciers, maybe like, I don't know, 75% of what's ever been collected on alpine glaciers is probably there. I mean, that's a guess, but it's, again, you know, people are steadily working on improving that situation. You know, and then we have some other sort of starter projects like Laurentide and Scandinavia that haven't really got very far. But, you know, once somebody kind of adopts them and like really gets into it because they want to do something with it, then they tend to expand quickly. So that's kind of the overall situation. I don't know if that really answered your question, but
no, Greg, that's great. I'm not sure there really was like
yeah.
an expected answer to the question. I was just kind of coming out of curiosity, and honestly, to hear you talk more about how much of it has been growing from the users as contributors, as Joe was explaining at the beginning, like that's like an uplifting.
Yeah,
I mean,
it's sort of
to realize it works that way.
What you lose there, and this is the part of this whole project that kind of freaks people out, is that there's not really a central authority for data, you know, review or certification or something of that nature. And this is very different from many previous projects that are more designed for archiving. You know, we don't have a review process or a single person who like certifies everything is accurate and so forth. So we've sort of taken the approach of being inclusive and assuming that, you know, we can't assume that there aren't any garbage data in there, but even if it was like highly curated, there would probably still be garbage data in there. So whatever you do with it, analytically wise, should probably assume that there are some garbage data. But if there are enough data, then the importance of garbage data becomes less and less. So essentially, we've taken a very different approach to previous sort of archiving concepts and sort of tried to make this more of an inclusive research tool, which is kind of more of a social engineering project, right? I mean, you could almost envision this as almost like a social networking kind of concept for exposure dating, right? Like, you know, even though we don't have any like social networking features, like you can't like other people's samples or something, but yeah, so we've been attempting to just do it a different way, and so far it's been working fairly well. And what really makes this work is that people realize, essentially, what we try to do in these workshops is we try to get people to realize like how much better science you can do if you can do things sort of programmatically from a centralized database. Like if you need to make figures or proposals or whatever, you can do it so much easier if you can sort of programmatically suck information out of this kind of central location. And I think that certainly for me and hopefully for others, the sort of, you know, persistent worry about revealing unpublished data to the world, whatever the cost of that is outweighed by the benefit of being able to use those data together to do whatever science you're trying to do. So yeah, we're doing it a different way, and it's like working pretty well.
So Greg, if I can just follow up with you, and also Joe, if you want to comment as well. I'm curious what your impressions are of the highest priorities and greatest needs for ISD at this point, in terms of, expanding and building and making it more complete. Are there specific geographic locations? Are there specific time intervals? What are your priorities right now?
Well, we're trying to. I mean, Joe may have different priorities than I do, but in general, I mean, we sort of actually scheduled a workshop to try to get a little better on the Laurentide ice sheet. So try to get some of the Laurentide ice sheet information in there in a more coherent way. There's some interest in Scandinavia in getting the Scandinavian ice sheet organized as well. So there are some people working on that. In terms of alpine glaciers, like Central Asia is actually like a total hodgepodge. There's like a lot of data in there. It's like pretty disorganized. I don't really know anything about the glaciation of Central Asia, so I don't even know like what sort of level of completeness we have, but we would really benefit by somebody who wanted to adopt Central Asia and get that organized. Yeah, otherwise things aren't too bad. We've had people kind of adopt like Greenland, New Zealand. Sean Eves has been keeping New Zealand up to date. The Western US is in pretty good shape for obvious reasons because lots of us are interested in that. And again, the French group did a bunch of work on South America, which was quite good. But yeah, nobody's really decided to wrap their head around Central Asia. That's not in good shape. So yeah, so great like student, graduate seminar project. Like
Yeah, sure.
Get the demystify the Central Asian stuff.
I think as well, we've been sort of expanding. I think both Greg and I come from the glacial world, but there's many other communities that use cosmogenic exposure dating. And so we have, I think I had mentioned earlier, we have a workshop scheduled for folks who use exposure dating in tectonic settings, like dating offset faults and calculating slip rates and things like that. So we're expanding into that realm of research. We worked with Brendan Quirk, who had done, I think for one of his postdocs, he had done some work on landslides and mass wasting kind of things like that. So we had him sort of start an application for mass wasting. We did one with with
the
John
floods.
Stone.
Yeah, that's right. There were some people in Seattle who were interested in setting up similar sort of. So I mean, the way we've got it. The way the back end works is that there's one database of all of the information, and you can kind of slice and dice that however you want. For example, you can see that certain samples could be from alpine glacial moraines, so they're relevant to an alpine glacier application, but the alpine glacier moraines have also been radiocarbon dated, so they're a production rate calibration site. So you have the ability to sort of to select a group of samples which may or may not overlap with other groups of samples, and make them their own application collection. Like, for example, the other thing is, a lot of glacial moraines have been dated, and they're interesting because they tell us when glaciers happen, but they're also offset by faults, so they're part of a tectonics database, right? So you can slice and dice the whole data set however you want to serve various geoscience applications.
Right. So Philip has his hand up, but before I would just put a plug in for maybe starting a FireD database for all the exposure ages on volcanic units and features. But anyway,
totally.
Philip.
Hi, Greg. I think this is Philip. You talk about Central Asia. I'm working on Central Asia, so I don't know.
Yes, you're just the person I want to talk to. Exactly.
Yeah. So is Jakob still working on this? I think Jakob.
So I haven't spoken recently to Jakob. I was kind of hoping that Jakob would abandon the Excel spreadsheet concept and join us. However, that does not seem to have happened. So the last I checked into this, which was actually a couple of years ago, he was still sort of keeping his giant spreadsheet up to date. But we have not attempted to do anything. We haven't attempted to programmatically ingest updates to his spreadsheet.
Okay. So what is the major problem of his Excel sheet? I think we kind of rely on him because I worked with him before.
So I mean, so his Excel sheet is not, it's just in terms of technical reasons, it is it's static and versioned, right? So it's not, so the advantage of using a MySQL database is it's a server, right? Like any application can connect to the currently up-to-date version of the database at any time. So we're not distributing versions of something. We have a central server that just serves whatever the current state of the database is. And that's preferable for data assimilation purposes and also simply for compatibility purposes, because all programming languages and computational environments have some way to connect to a MySQL database. So just simply in terms of infrastructure design, having a database server is preferable to having a static downloadable spreadsheet. Also because the SQL server provides query capability, of course, which is not available for an Excel spreadsheet. I mean, you can do, as you know, I'm sure, quite sophisticated data analysis using SQL, and then even more once you use bring the result of an SQL query into some other environment. So technically it's preferable to do it using a sort of distributed server infrastructure. The other thing is that his spreadsheet is quite limited in the number of in the data that are there. His spreadsheet really only contains minimal information about it contains only the minimum of information needed to compute the exposure ridge, latitude, longitude, amount of beryllium 10, etc. So it is not possible to associate additional information. For example, using a database, an online server type structure, we can associate all kinds of things. I mean, if you start browsing around especially the Antarctica ICD database, you will see that samples can be associated with photographs, with other documentation, laboratory records, things of that nature. So the SQL database is kind of infinitely extensible to be attached to other information and objects, which is not possible with the Excel spreadsheet. And finally, with the Excel spreadsheet, it's very difficult to implement sort of cross-cutting categories. For example, commonly, a publication, of course, describes multiple samples, and that's encapsulated in Jakob's spreadsheet where he's got everything grouped by publication. But of course, a sample can also appear in multiple publications, right? And those kind of relationships can easily be incorporated in a relational database, whereas you can't do them in a flat file. So there are many technical reasons that this system is preferable to the spreadsheets. And the other thing that's not really a technical reason, but we're essentially trying to build a centralized infrastructure that can be worked on by many people. So this is our whole kind of users as developers concept, is that it is way too big a job for me or Joe or Jakob or anybody to just keep up with all exposure dating everywhere. So we need to make this a project that many people can contribute to. So those are the reasons that we prefer this setup. At present, things are a little bit redundant because Jakob is sort of updating his own spreadsheet, and we're not actually pulling that information into ours. But that could be fixed. So that's the thinking.
That's great information. In that perspective, I think, I definitely can contact him, I'm definitely interested in this new infrastructure. I think I'm interested in this talk, in this, database-driven things.
Yeah.
I may be, I don't think I can volunteer, but I think I can coordinate, some effort in this perspective.
Yeah. Well, I mean, like, just take just go to the sort of website and kind of browse the Central Asian region through the maps or whatever, and you'll see that there are some problems. Like a lot of the geographic naming is incorrect, and there's
Yeah, I have to check
we have
that.
sort of we don't have a very good, I think we're missing a lot of data, but anyway,
I
so
checked the Tianshan work. I do know
Yeah.
they're missing some data, so that's something I'm interested
so
in update.
so and a lot of that is just that I don't even think about that part of the world very much, so I don't even know what we're missing. So yeah.
I definitely will contact you and Joe, to say, how to
Yeah.
learn this and then how to, manage to update this later.
Yeah.
Thank
Yeah, no, if you could attend one of these workshops, that would be cool. Actually, that would be very useful because you obviously have some expertise in some of these areas. But we could also schedule something just on the phone with Joe so he can give you the orientation on how to do everything too.
Yeah, I'm definitely interested in the online GS part, Joe talk about in this, I work on a lot of Python programming ArcGIS perspective, definitely want to learn, go down. That's right. Okay, thank you very much.
Yes.
Okay, so we're at the top of the hour here, and I want to announce our talks for next week. But Cal, do you have a quick question, or maybe you could ask Joe offline?
I was just going to ask, when will the server, like the viewer server, be available? When can we get a link just to look at that?
Oh, I put some stuff in the chat. There's some
okay.
URLs in the chat window.
Great, thanks.
Okay, great. So let's wrap this up then, and thank Joe again for a really awesome talk that obviously inspired a lot of discussion, and also the input from Greg as well. So really great session this week. So next week we have, it would seem, if I'm correct, and Leif, you could correct me if I'm wrong, but I think that we're up next week, aren't we? So Leif and I are going to be talking about Paleoglacier outlines and how to draw those and how to not draw them and how to go about not knowing how to draw them. And then we're going to be hearing also from Ben, also Leif as well, about database development. So that's next week. That's March 3rd. So it's another Friday. So we're not reverting back to Thursday. So if you put it on your calendar for Friday, and I think that Ben will probably put the email out for that relatively soon. This was sort of a one-off with the Zoom link that I created, but we'll probably go back to Ben's Zoom link next week. But just stay tuned for the email with the details about that.
Joe?
Yeah.
Just quickly before we leave, just clarification. I misspoke at the beginning, although I may have been muted, so it may not have mattered, about the deadline for Rocky Mountain GSA. It's in 4 days. It's the 28th.
Oh, I have an extra day.
So you really got to get going. But yeah, so if you want this past glaciation Western North America session, if people want to take part in that, that's you got 4 days to.
Excellent. Thanks, Eric. I really would like to. I mean, I wouldn't mind being a spectator either at a lot of great sessions, but 4 days. Okay. Thank you for the reminder.
Right.
Okay, great. Well, I guess happy Friday, everybody. And hope to see you next week. Thanks again, Joe.
Thank you, Joe.